Trying some numbers out in this question is the way to go, I think. Just sort of thinking about it, seeing if you can find a counterexample. You could also go a step further and try and prove some of these things. So I'll go with the intuitive feel for each or counterexamples, and then I will prove the ones that are true at the end. So a prime multiplied by a prime is always a prime. Well, actually, this is in fact never true because then it will have extra factors. It will have the primes as factors as well as the number itself and 1. So 2 times 3 is 6, which is clearly not prime. However, a square multiplied by a square is always a square. Well, 4 times 9 is 36, which is a square, and you could try some other ones. It is always true. Actually, let me prove that one right now. So if I have a square number, then it's going to be x squared. If I times it by another square number, say y squared, then this is actually x squared y squared, which you can write in brackets as xy all squared. And that essentially means you've got a square number because it's a number times that number, and then we're squaring it. So that would be a proof. An odd number multiplied by an odd number is always an odd number. You might have an intuitive feel for this. It is always true. And an even number multiplied by an even number is always an even number. Same sort of thing. 2 times 6 is 12. So that one's true as well, and the answer is D. Let me just prove these later ones. I'm going to start with the even numbers. So I could call an even number 2n, where n is an integer, and I could times it by another integer, 2m. Got to make sure it's different because it's not necessarily the same. And that will equal 4nm, which is also a multiple of 2, so it will be even. And that's enough. That is a proof. We could do similar for odd. It's just that odds are a little bit more complicated. So I've got an even number. If I want to make it odd, I will need to add 1 or minus 1 or add 3. But adding 1 seems to be the simplest thing. And then I'm going to times it by another odd number, say 2m plus 1. If I multiply out these brackets, I did say this one's a bit more complicated. I'm going to get 2n times 2m by doing this one. Then I'm going to add 2n, add 2m, and then add 1. And I can actually factorize a 2 out of the first 3 expressions, which will give me 2 times 2nm plus n plus m. I've still got a plus 1. Now this thing here will be even, so when I add 1 to it, it will be odd. So those are algebraic proofs for the last couple statements.